students. So today I'm starting with the topic of operations management, and in this we start from linear programming problems. So first, before starting, let us know what is a linear programming problem. So nowadays we see that big companies make losses even after working hard because they don't use their resources optimally. So today I will show you a simple technique used by companies like factories, airlines. So they what the technique they use is linear programming. Imagine you have a limited money, limited time, and limited machines. You can produce many products, but you must decide how much of each product to make. If you choose wrongly, you lose money, and if you choose correctly, then you obviously maximize profit. So, this is what a linear programming problem is. So, a simple linear programming problem, for example, might look like a maximization of profit, for example, Z equal to say 40x1 or 20y2. So like this will be our objective. So now I'm starting with the linear programming problem, like with the basic assumptions of it. So firstly, there is an objective of it. Then in every part of industry, we see that there are constraints also involved. So for example, if manpower, say it is M, manpower is M, and machinery is M1, or you can say the budget is only of, or say, B. Okay, so now we have a constraint here that if for every manpower, for example, there is 200 rupees per day, and for every machinery we spend 400 rupees per day. So now these are the constraints in a LPP. So just I am giving it as an example. So further what we will do, we will start by solving, not solving, but by formulating some linear programming problems. So we will be formulating, because before you can get to an optimal solution, which is the main focus of LPP, that is optimal solution finding. So what is an optimal solution? So if you have to maximize this profit, then there could be n number of machines and m number of, for example, say, manpower, and also time and everything which is constrained in nature. So all that you have to think about it, and at what condition we are reaching a maximum profit, that will be our optimal solution. So there could be solutions which are giving profit, and there could be solutions which are giving losses, but we have to find the maximum profit giving scenario. So that is the case in linear programming problem. In very simpler words, I have told you. So now let us start with some problems. So for example, I am taking a simple problem here. Let us understand that what it is saying. So a retail store stocks two type of shirts. So it is saying that a retail store has to store two types of shirts, A and B, and these are obviously packed in cardboard boxes. And let us see what the question is saying. During a week, the store can sell a maximum of 400 shirts of type A. So by just by looking at the sentence, we can know that it is a type of constraint here, because the maximum of shirt A we can sell is 400. So 400 is maximum of A. After that, let us read ahead, and a maximum of 300 shirts of type B. See, so now 300, we know it is the maximum of B. So whenever a question is saying or stating something like it is a max or min, so that is a constraint here. So we are starting to formulate. So after that, let us see 600 types of both combined. See, however, is limited to a maximum of 600 types of both combined. It means that A and B cannot be more than 600. Okay, so these are the constraints. We will write further, but first we have to know what the question is saying. Now about the profit. See, profit of 2 rupees per unit of type B at a profit of 5 rupees per unit. Okay, so A fetches 2 unit, A is fetching 2 unit, and B is fetching 5 unit. Okay, so what we have to do is formulate a mathematical problem. Okay, so see, in simple words, you can understand that what is a profit is a good thing. So we need to maximize this maximize this profit. Okay, so now we have to formulate an LPP. So how do we do it? So firstly, as I told you previously also, there is an objective. Our objective here is to maximize profit. So you can take something like maximize Z. Okay, maximize Z is equal to. So let us consider you store a number of A shirts and small b of B shirts. That is how what you store. You have to write this in exams also if you are giving a subjective kind of paper. So firstly, this is the basic. So A is giving a profit of 2, B is giving a profit of 5. So we have to maximize that. That is 2A plus 5B. So that is the maximize of Z. After that, let us see at the constraints. Here it was given that A is maximum of 400. So A must be equal to less than 400 and B should be less than equal to 300. But together A and B are less than equal to, how much is it given? It is given as 600. Okay, so A and B is together less than equal to 600. Here it is. So now this is a formulation of an LPP. And also don't remember that both A and B are greater than 0, because this is the basic assumption which we use in LPP. So if this question, like you see, so first we, like, just I'm giving a conclusion of it. So first we, what we do is understand what the question is saying. So here the question said that the maximum unit of A could be 400, maximum unit of B could be 300. So we assume that let A be the stored units of A, B be the stored units of B. After that we maximize this profit here, because if there is a profit, we already know that it is a maximization problem. After that, let us look at the constraints. Maximum of A, as I wrote, 400, maximum of B 300, and finally A plus B together cannot be more than 600. So that is the formulation of an LPP. So this was one problem which I have taken. Now this was a maximization problem, which was very like the most basic problem of all. So after that, let us move ahead and go to a next problem. So let us read this problem now and try to understand what is happening here. A ship has three cargo holds: forward, after, and center. Okay. The capacity limits are: forward 2000 tons and the space which it is having 100,000 cubic meters. Similarly, for center it is given and for after also. So what it is given that there could be three positions in a cargo, and the amount of, like, what like the quantity what you can store is 2000 tons, 3000 tons, and 1500 tons in all the three cases. And the space which you will have, you will be having maximum will be, it is given like 100,000, 135,000, and 30,000 cubic meters. So let us start formulating this problem. So what we have to do is, like, profit is given for A, B, and C. A, for profit, A is 60, 80, and 50, as you all can see, so I won't be going ahead on that. How should the cargo be distributed so as to maximize profit? Formulate this a linear programming problem. So again we have to formulate this and this problem. So let us consider that A, B, C, A, B, C. So this be commodity be A, and B and C. Like here you can see that A, B, C. So we take small a, B, and C as an assumption that let us take an amount of commodity A, B, and C. After what? After that, we will do a maximization. Like we all can see here, there is an objective of maximizing the profit. So profit for A is 60, B is 80, and for C it is 50. So as we did in previous question, maximize Z is equal to 60A plus 80B plus 50C. So this becomes our objective. So like for in formulating an LPP, it is very easy to make the objective function because it is clearly visible. The objective function because it is clearly visible. Now constraints we have to make. So look at the constraints. What can be the constraints here? We have made the objective. After that, now let us see that what is the space available for A, B, and C respectively. So here amount in tons you can see is 6,000 and volume per ton in cubic meters is 60. So the space for A will be 6000 upon 60, that will be 100. Okay, so for A we got that space is 100. Now similarly you can write for B and C. So for B is equal to C, 4000 upon 50, that comes to be 80, and again C is equal to 2000 upon 25, which again comes to be 80. I'm writing here because okay. So now the space we have written. So let's see that space for 100, like A is 100, because okay, so A, B and C we have taken 100A plus 80B plus 80C. Now this is the space we are talking about, so it would be less than equal to C. Space is 100,000 for A, maximum space I'm talking about, for 135,000 for B, and again 30,000 for C. So if we all these maximum spaces, what we get is that 2,65,000. So this is one constraint here, C1. Okay, this was the objective function, this is C1. After that, this is one constraint. After that, now amount in tens. So 6,000, like if we assume that, like we assume that A is the amount of A, so 6,000 A plus 4,000 B plus 2,000 C. Now what this should be, the max it could be, see here, this side I'm like I'm indicating you here in this video. So see, forward 2000, center 3000, after 1500, so that comes equal to be 6500. And obviously we know that A, B, C all greater than equal to 0. So this was the second question. So in this question also, let me conclude that the objective was to maximize profit. What we first did is took an object, like I told you, maximize that, and the objective was maximizing profit, so we did this. So this was our first equation. Don't focus on solving, I will be in the further videos, I will explaining how to solve these LPP. So right now the first step is to formulate, so let's focus on that only. Now after that, what we did, that we took the spaces, like what was the maximum space for A, so it was 6000 upon 60, similarly 4000 upon 50, and 2000 upon 25. This came to be 80, 80 and 100. So this was the maximum spaces, and then these maximum spaces should be less than 100,000, 135,000 and 30,000, coming up to 265,000.